Hello everyone and welcome back. My name is Mr. Cobalt and today in this video I am going to cover balancing chemical equations. So in this video I just want to kind of go over an example and just go over the steps of how you should approach a balancing equation type problem. The first thing you want to do is you want to be able to translate the equation or what they're telling you into an equation. So a lot of times they're going to give you something in words, and then you're going to need to be able to translate that into an equation. So for example, if they tell me in words like, okay, so you have some methane and you burn the methane and the methane burns to create carbon dioxide and water, and they say all this in words. So you need to be able to go from the words to the formulas for the reactants and products. So that's the first thing you want to be able to do. If they don't give you the formula right off bat, they don't give you the equation itself with the formulas, then you're going to have to provide that yourself, given the information that they're giving you. So in that example where they told me, okay, we are burning methane to produce carbon dioxide and water, then you need to come up with the fact that, okay, so in this case, I have methane. You need to know the formula for methane, CH4. So I have a gas, CH4 gas. That's going to burn. Anytime you burn something, it's assumed, if they don't say, that's going to be reacting with oxygen. So that you need oxygen for combustion. So that is going to be a reactant. So O2 gas. And you need to know that that is a diatomic element, so it's O2, not O. So oxygen gas, so methane plus oxygen gas is going to give me carbon dioxide and water. Carbon dioxide is a gas, water is a liquid. It could be considered a gas if it's water vapor. So here is the skeletal outline of the formula with the reactants and products. So you need to be able to do that if it's not already given to you. So once you have your skeletal structure with all the formulas properly written out, at this point you're not going to change the formulas. So you're not going to change the subscripts. You never ever change the subscripts once you have the formulas correct. So the only thing you're going to change at this point are the coefficients. So, and that brings us to the rest of the rules. So step 2, you're going to balance the atoms that occur in more complex substances first. You're always going to balance the compounds, the atoms in compounds, before the atoms that occur in pure elements. So here I have carbon is part of a compound, carbon is part of a compound, hydrogen is part of a compound, as well as here. I have oxygen here as a free element. So I'm going to balance the compound. I'm going to balance the atoms first that are in compounds, and the element or oxygen I'll save for last. That's step 3. Okay. So then what I'm going to do is I'm going to look here, and you usually start with if you have a metal, then you're going to start with a metal. If you have you're going to do the metals first. And then if you have non-metals, usually you start with carbon and the other metals. And a lot of times you'll leave oxygen and hydrogen last. But it all depends on the problem. So usually you balance metals first, and then you move to non-metals, and then so on. So here we don't have any metals, so I don't have to worry about that. So I have carbon. I'll start with the carbon. So I have one carbon here, one carbon here. So that's already balanced. So that's good. And so now I need to look at the hydrogen. So I have 4 hydrogens here, and I have 2 hydrogens here. So I'm not going to change subscripts. So if I have 4 hydrogens on this side, I need more hydrogens on this side. So I could either do 1/2 on this side, or I could do 2 on this side, because 2 times 2 is 4. And that would give me 4 hydrogens on this side. That's going to be the better way to go, because if I put a 1/2 on this side, I'm gonna mess up my carbons as well as the hydrogen. So if I do a 2 over here, Usually you want to try to do whole numbers if possible. Okay, so you're going to do whole numbers if possible. So I'm going to put a 2 here. So 2 times 2 is 4. Notice I did not change the subscript. I just changed the coefficient. So 4 hydrogens, 4 hydrogens. 1 times 4 is 4. 2 times 2 is 4. So if you want to count the atoms, you can always multiply the coefficient by the subscript. That'll give you the total number of atoms contributed by that particular compound. Okay, so I have 4 and 4, so that's good. I have 1 carbon, 1 carbon, that's good. So the only thing left is the oxygen, and so now I can go to step 3, balance atoms that occur as free elements on either side of the equation. So here I have a free element on this side, so I save for oxygen for last. So now I want to balance the oxygen. So I have 2 oxygens here, and I have 2 oxygens here, and since I have a 2 there, it's 2 times 1 is 2. So I have 2 from this, from these waters, and then I have 2 from the carbon dioxide. So that's a total of 4. So I have 4 oxygens on this side. So I need 4 on this side. So I can't change the subscript. So I need to be thinking coefficient. So what times 2 gives me 4? Well, 2 times 2 gives me 4. So that tells me I need to put a 2 in front of the oxygen. So now I have 4. So 4 and 4 on this side. So now my oxygens are balanced, and I didn't have to balance anything else. That's why you save the free element for last, because you can balance the free element without messing up everything else that you balanced. So once you get to the free element, you may need to use a fraction here. Notice I didn't have to use a fraction to balance my oxygen, but sometimes you do. Sometimes you need to put like 1/2 or 2/3 or something like that. In that case, if you have a fraction, then you need to get rid of that fraction by multiplying the whole equation by the denominator of that fraction. So all the coefficients would be multiplied by that denominator. So if you have a 1/2, then 1/2. So for example, if you have 1/2 as a coefficient in your equation, then you would have to multiply every coefficient in the equation by 2 to get rid of the 1/2, and yet keep the balance. Keep the balance of the coefficients. If you had something like 2/3, right? So if you had something like 2/3 of a fraction, then you would multiply by 3. So every coefficient in the equation multiplied by 3. But we don't have to do that here because we don't have a fraction. So this is your balanced equation. So you can double check. So 1 carbon, 1 carbon, and then I have 4 hydrogens. I have 2 times 2 is 4 hydrogens, and then I have 2 times 2 is 4 oxygens. 1 times 2 is 2, plus 2 times 1 is 2, so 2 and 2 is 4. So I have a balanced equation. And so that's how you do a balanced equation. Just follow these 4 steps and you should be fine. Okay? In the next couple of videos, I will go over some examples of balancing equations so you can see more of how it's done. Thank you for joining me. I hope you enjoyed this video. If you did, please like the video, share the video, subscribe to the channel, and make a comment down in the comment section. Let me know what you think, if there's anything else that you would like me to cover. And also make sure you ring the bell for any notifications of any videos I put out. Thanks for joining me, and I'll see you next time.